In order to find the value of the limit, we can begin by directly substituting in 1 for x in our function. And this is going to give us 1 over the natural log of 1 minus 1 over 1 minus 1, which is going to be 1 over 0 minus 1 over 0, which gives us infinity minus infinity, which is an indeterminate form, but it's not 0 over 0 or infinity over infinity, so we can't apply L'Hopital's rule. So we need to change the form. And the way we do this is by combining both our fractions into a single fraction using the natural log of x times the quantity x minus 1 as the common denominator. Once we've done that, if we substitute in 1 for x, we're going to end up with 0 divided by 0, and now we can use L'Hopital's rule. So L'Hopital's rule states that if you have a limit that ends up giving you one of those two specific indeterminate forms, then there is an equivalent limit that you can get by taking the derivative of the numerator of your fraction and placing it over the derivative of the denominator of your fraction. So we're going to take the derivative of x minus 1 minus the natural log of x and place that over the derivative of the natural log of x times the quantity x minus 1. This is going to give us the limit as x approaches 1 of 1 minus 1 over x, and that will all be over x minus 1 over x plus the natural log of x. Now, if we take this expression and we again substitute in 1, we're again going to get 0 over 0. So this tells us we can apply L'Hopital's rule again. Now the problem with trying to directly apply L'Hopital's rule again is we have a couple of things that look like they might need the quotient rule, or a couple of things that are going to get a lot more complicated as we keep taking derivatives. So what we're going to do to simplify the numerator and the denominator is we're going to multiply by x over x. So we're not changing the value, but this is going to make our set of derivatives easier to deal with. So this is going to leave us with x minus 1 in our numerator and x minus 1 plus x times the natural log of x in our denominator. And if we take the derivative of our numerator and denominator, we're going to get a new limit, and that's going to be the limit as x approaches 1 of 1 over 1 plus the natural log of x plus 1. And now, if we use direct substitution and plug in 1 for x, we're going to end up with 1 over 1 plus the natural log of 1 plus 1. And the natural log of 1 is just 0, so this gives us 1 over 1 plus 0 plus 1, or the final answer to our limit, which is 1/2.